And again, welcome to the webcast today, Customizing AWS OpsWorks with Chef 11 and Amazon Machine Images. Our presenter today is Chris Barclay, Senior Product Manager at Amazon Web Service. Chris, you have the floor.
Thank you, and thank you all for joining us today. I really appreciate you taking the time. I'm going to give a quick overview of OpsWorks, and then we'll jump into a demonstration and show you a bit of the features as well as the new features that we released a couple weeks ago. So without further ado, let me just kind of jump into the meat of our presentation here. So for those of you that aren't familiar with OpsWorks, OpsWorks is a DevOps-oriented application management solution. So if you develop or manage applications, you probably know that there's a number of complexities, not just around the coding, but operational responsibilities too. And so your tasks that you are operating with on your application and your instances, you want those to be predictable. There's certainly nothing worse than trying to diagnose operational problems in a live application. And you want to be able to configure and control any aspect of your application. You need a tool to do that that's powerful and flexible enough to support a wide range of application architectures. And you probably also want something that's easy to use. So, once upon a time, we used to handcraft our environments. We might do everything from provisioning hardware to getting the software on the instances to installing it to configuring it all by hand. And that's certainly nice when you have the time, but it's hard to ensure repeatability, especially when you get to scale. And oftentimes repeatability is pretty critical for making sure that your application runs well and runs reliably. And what we really want to be able to get to is a situation where we have consistency. So any new instance we provision looks exactly like we want it to. There aren't one-off things that you have to do on those instances to get them into the state that you need. And so what OpsWorks lets you do is create recipes that describe how you configure your environment, and we provide automation that ensures consistency across all of your resources. And because you probably don't have only one variety of how you want your instances to be configured, you might have load balancers and caching and search and all sorts of other sorts of components to your application, then we recognize that you may have different types of recipes and different types of configurations you want to perform, and we give you that ability as well. And so an important point that we think is that code is not only the output that you're writing for your application, but it's also the configuration of your environment and the servers that your software runs on. And so it's everything from provisioning the servers to configuring the servers to deploying your applications and then the application code itself. And once you have all those components written in a language that lets you kind of check that into source control, then you have a much higher degree of repeatability and predictability in your environment. And so OpsWorks is a tool that we've developed that brings this all together for you. It gives you all the tools you need to manage your application, and perhaps best of all, you pay only for the resources that you're using. OpsWorks itself is a free tool from AWS. So just a couple quick descriptions of why you might want to use OpsWorks. OpsWorks is very simple to use, lets you deploy your application quickly. If you don't have any customizations that you want, you don't have to do any changes. You can get up and going in just a matter of minutes and get your application deployed. We provide a nice management console as well as CLIs and an SDK so you can automate your application to any degree you want. And we provide built-in support for common frameworks and tasks. We provide also a highly integrated experience that makes you productive so you can model and reproduce your application configuration reliably. It's a flexible tool that supports a wide variety of applications and any software that has a scripted installation. It's powerful, includes an event-driven configuration system with support for customizable deployments and rollback and patch management, auto-scaling, and more. And finally, it's secure. We have default security groups and permissions for IAM users, including things like SSH and sudo on a per stack basis. We have a number of customers that are using OpsWorks today. I encourage you to take a look at the case studies that we have on the website. And these customers are getting a number of benefits from things like being able to ensure more consistency and reduce time that it takes to run their applications because of the automation. So it might just be helpful for me to describe a few different ways that we see customers wanting to deploy software on AWS. One way is what we call image-based deployments, and you might be familiar with these with Amazon Machine Images, or AMIs. And what you can do here is you can install all the software that you want, and you can basically bundle your own AMI. You might have seen some of these AMIs that are available in the AWS Marketplace, or even in the AMI catalog when you launch an EC2 instance. And this can be pretty helpful for being able to include all the software you want and not have to worry about configuring software when you deploy new EC2 instances. The challenge with this approach, of course, is that you have to actually create that AMI. And so it's a little bit less flexible for performing updates and pushing down patches and things like that to your running instances because you'll want to create a new AMI. Another approach is a container-based approach where you install a bit of the software that you don't change as frequently, and then you push your code into that existing AMI. You sometimes see this with tools like Elastic Beanstalk. And so if you just want to kind of push your code to the cloud and go, then a tool like Elastic Beanstalk might be really good for you, and this approach might work well. And then the final software deployment option is to start with just your base Linux, or base operating system, Amazon Linux, Ubuntu, or even Windows, and basically install your software using a layered approach. And you might use a tool like Chef or Puppet or AWS OpsWorks to get your software on those boxes. And of course, this requires you to install the software when the instance boots, so it can be a little slower as far as getting the instance fully configured, but it also gives you a lot of flexibility on managing updates. So you can change your chef recipes, for example, or whatever your software installation scripts are very simply without having to bake a new AMI. And of course, you can see some examples of combining these as well. We'll talk a little bit about that in today's demonstration with OpsWorks support for custom AMIs. Now, those software deployment mechanisms map fairly well to our AWS application management services as well. And the AWS application management services give you additional ways to really deploy your applications without having to worry about all the underlying services. So Elastic Beanstalk, for example, is a very easy-to-use solution for building your web apps and web services with popular application containers like Java, PHP, Python, Ruby, and .NET. And if you want to just upload your code and go and don't need to customize your environment very much, then Beanstalk may be a good solution for you. CloudFormation is a building block service that lets you provision and manage almost any AWS resource. And it's powerful, but it does require you to author templates in a domain-specific language. And it doesn't provide out-of-the-box functionality for things like application deployments. OpsWorks, on the other hand, is a powerful end-to-end solution that gives you an easy way to manage applications of nearly any scale and complexity with an integrated experience for managing that application lifecycle. So let's talk a little bit about what we're going to show inside the demonstration today. First, what we're going to do is we'll create a stack. And a stack represents all the resources you're using as part of your application. It's all of the various AWS resources as well as the things that you're bringing, such as your application code and configuration scripts. Inside the stack, we divide that up into what we call layers, and a layer defines the blueprint basically for how you want to configure your EC2 instances. So it's everything from the volumes you want to have attached to an instance when it boots up to the software you want installed on that instance. And then you can decide what kind of instances you want, if you want ones that are on all the time or if you want them to scale with load or time. And then, of course, you're going to want to deploy your app to those instances, and so we give you a mechanism for performing application deployments too. Now, one of the things that that OpsWorks provides is integration with Chef. OpsWorks includes something we call lifecycle events that trigger during the course of your application, such as when an application or your instance is provisioned or your application is deployed. And this lets you perform specific configuration tasks using Chef recipes that are attached to those events. Metadata is automatically generated by OpsWorks for such information as the instances running on in each layer and layer-specific parameters. You can also specify metadata yourself that's passed into the recipes. So let's take a look at an example. So here we have a recipe, and this shows that you can generate a database connection string automatically, and we'd want to automate that so we can ensure repeatability. So we don't actually hard-code the database connection string into our application, but rather we build it dynamically through a Chef recipe. So Chef takes the metadata that you see there in the middle and plugs it into the recipe, and that generates the command. And so that command then can get pushed into our application source code, and we'll show you the recipe in action in the demonstration. So just a little bit more about OpsWorks and Chef. OpsWorks uses Chef Solo to configure the software on the instance, but it provides many of the Chef server functions to you as well. So for example, it lets you associate cookbooks with layers, which then are of course associated with instances. We provide dynamic metadata that describes the nodes in your infrastructure. And the benefit of this dynamic metadata is, for example, if you had a proxy server layer and you wanted to be aware of when instances in your app server are booted or when they are turned off, then the events that we generate can alert the recipes in that proxy server layer so you can kind of start routing traffic or turning off traffic to those new or terminated instances. We also support the ability to push commands and control client runs from the service. So you could push a recipe at any time to any instances that you want. So this lets you perform specific tasks, like maybe you have some sort of runbook automation for when you have certain alarm types, and you may need to do things like bounce a web server. All those things can be automated and performed centrally from the server. And then, of course, with the Chef 11 announcement that we made a couple weeks ago, we give you broader support for community cookbooks. And just to kind of summarize some of our recent launches, we've launched over the past couple months support for Elastic Load Balancers, CloudWatch Metrics View, and then, of course, the recent Chef 11 and custom AMIs. So why don't we go ahead and I'll set up a screen share and show you a little bit more about a demonstration of OpsWorks. So what we're going to do in our OpsWorks demonstration is first we'll create the stack. So let's go ahead and we'll name the stack our web service. And you can see that OpsWorks gives you a number of options. You can choose the region you want your stack to be deployed in, the availability zone, the default availability zone, and of course you can override this for any of your instances. So if you wanted to have your instances spread across AZs for more reliability, you can do that. Your default operating system, so Ubuntu or Amazon Linux, and we'll choose Ubuntu for this demo. Things like your default root device type, your service role that you're using to create your instances, and so on. And we can see here that there's also an advanced section, and inside this advanced section we can see the Chef version that we're going to use, and so we're using 11.4. And we're going to use some custom cookbooks for this demonstration. So I actually created some Chef recipes that perform additional configuration on my servers, and those cookbooks are available here inside my Amazon Web Services sample cookbooks. So let's go ahead and we'll go get those. So I'm going to go ahead and take this URL. These are all available on GitHub in case you want to take a look at them yourself. And I could have kept this in a private repo, and so if so, I would put the repository key. We also support additional repository types like Subversion or even just simple S3 bundles. And I'll go ahead and create my stack. Now the next thing I want to do is I want to add some layers. And so the first layer I'm going to add is an app server. And in this case, my application is a PHP app, so I'm going to go ahead and add the PHP app server. I'm not going to use ELB for this, although I certainly could if I wanted to route traffic across multiple instances. But I'll go ahead and create my PHP app server. And I'll also go ahead and create, in this case, I'm going to use MySQL database. For this simple demo, I'm just going to install MySQL on an EC2 instance, but I could also use RDS if I didn't want to have to manage my own database, and that's oftentimes quite a bit easier. And now let's go ahead and we'll add some instances to these layers. So let me go ahead and I'll create a couple 24/7 instances, one for each layer. And then let's go ahead and we'll start all of our instances. Now there's, as I mentioned inside the presentation, we also have the ability to create time-based and load-based instances. So let's take a look at those. So if I wanted to scale up my PHP app server, and perhaps I know that I always have demand from 9 to 5 Eastern time every day, I could go ahead and create some instances that could help manage that load during that period of time. So I would just go ahead and add the hours that I want that instance to be on, and it'll go ahead and turn itself on during those time periods. Likewise, I could also create a load-based instance, and that could be triggered based on CPU, memory, or just average load on the server. And these metrics are being collected all the time from instances that are running, and those metrics end up going into the monitoring view. And so we'll take a look at those metrics once our instance comes up and running. So this gives you a lot of ability to handle the load that your instances are getting from your users. Now, how do we actually configure the instances? Well, the instances are configured based on the layer. So let's go ahead and take a look at our PHP app server layer. So we can see here that there's built-in chef recipes. In fact, there's 20. And this is these recipes let me configure, let OpsWorks configure for you the server to have a PHP flavor. And so you can see things like Apache being installed, PHP being installed with Apache. And if you click on any of these, you'll actually see the recipe that we used to create this for you. So you can actually see inside our public GitHub repository all of the built-in recipes and cookbooks that we include. And so you can kind of see what we perform in order to get Apache configured on your instances. And then as we scroll down, you can see we also have a spot for custom chef recipes. And in this case, I want to include a custom chef recipe that's inside my PHP app directory here. So we'll look in recipes, and we can see that we have an app setup recipe. And what this does is sets that connection string, as I mentioned, to my database. So taking the host name, username, password, database, and the table, and constructs that for me so I don't have to put that in my source code. So let's go ahead and we'll put that into our recipe here. And I'll add that recipe to my layer. Now the layer also includes a number of other attributes. So for example, you can identify the elastic load balancer that's routing traffic among your instances. You can actually add EBS volumes in various RAID configurations to your instances. So this all saves you the time of having to do this yourself. And also it's nice because you know that it's going to happen whenever you create a new instance. You don't have to worry about changes that you may or steps you might forget. You can also install additional operating system packages. So if there's things that you want to have installed whenever your instance boots, you can set them up to be installed here without having to worry about writing a chef recipe. And then OpsWorks also includes something called auto healing. So if your instance stops responding to to traffic and it's not in a good state, then we can go ahead and stop it and restart it. So I'll go ahead and save that layer configuration, and now let's go ahead and we'll take a look at the MySQL layer. And just like the PHP, you can see that we have a number of built-in chef recipes that configure MySQL and basically deploy the MySQL code. And then, of course, we're going to have a custom recipe that I'll go ahead and add as well. And so here we have PB set up. And for MySQL, we'll have a persistent data store that's already configured for us, so a drive that's on vol MySQL. And we'll go ahead and save this configuration as well. Oops, forgot a semicolon there. That was helpful. Okay, so now we have our layers set up. Our instances are booting. And why don't we go ahead and we can configure our apps while the instances finish booting. Now, while the instances are booting, then they'll be configuring the software that is part of the layer. So that's kind of part of the process that's happening right here. So we'll go ahead and add an app. So here's my app. And you can see that the default is PHP. We have a link to your source repository. And so we're actually using OpsWorks cookbooks again here. So let's go ahead and we'll go back up here for our cookbook, our application repo. Oops. Let's see, we want OpsWorks demo. Excuse me. So here's our cookbook where all of our application code is. So I'm going to go ahead and put this into and in this case, I'm going to use version 2 of my app, so we can see this is kind of an easy way for us to deploy new versions. We can go ahead and just update the version flag here and push that out. And I'm going to go ahead and add my app. So now I have an app. I have my instances that are booting. And let's talk now about custom AMIs. So as I mentioned, the PHP app that's running here is basically has the PHP recipes that have been configured, and so now I have on this instance the Apache installed, my PHP installed, and all the software I need. But one of the things that I always like to have on my instances is the Amazon AWS CLI, and so one of the things that I'll want to do is connect to my instance and be able and install the CLI so that I can be able to use it whenever I might need to do any sort of diagnostics. Now, in order to sign on to my instance, traditionally people install a single SSH key for their EC2 instances, but one of the benefits of OpsWorks is you can actually have user-based SSH keys. So I can go ahead and give user CB SSH and sudo access to this box, and so that I'm able to sign on with my individual key. And what this lets you do is if that user were to move to a different project or something like that, you can just as easily disable their access on a user-by-user basis. Makes it a lot easier for you than having to kind of do key rotation on all of your instances. So now I'm able to sign on to those instances and perform actions on them. So I'm going to kind of go a little bit off script here and see if I can, nope. Unfortunately, I'm on a different laptop than I usually am, so I don't have access to my PuTTY console and my SSH key. So I'm going to probably have to not show you actually logging onto that box and installing the CLI tools. Let's assume that I had actually done that. So let's say that I want to go ahead and package up this instance into a custom AMI. One of the things that you're going to want to do, in addition to installing the whatever software you want on there, if you're using an existing OpsWorks instance, you're going to want to follow the steps to basically turn off the agent and then package it up once the agent's been turned off. The reason for this is that the agent includes a unique identifier, and so if you package that up with your AMI, then that unique identifier will be created on any subsequent instance that's created with that AMI. So we want to kind of take that unique identifier out. So if you're working on this yourself, then take a look at the documentation and the using custom AMIs, and follow the steps if you're using an OpsWorks instance to remove that. Of course, you can always start from a base EC2 instance and install the software you want as an alternative. And so the documentation kind of walks you through that. So I apologize, I won't be able to show you those steps visually in the demonstration today. What I can do, though, is I can take you to EC2 and kind of show you how that would manifest itself in the EC2 console. So when you go into EC2, you can see when you look on the instances view, the instances that we're actually running. So you can see my DB master for my web service and my PHP app. And so what you'll want to do is to create your AMI, following the instructions in the documentation, is once you've removed the OpsWorks agent, you'll stop the instance in OpsWorks, and then you can create your AMI. So let me go ahead and I'll stop the instance in OpsWorks, and we'll create an AMI here for you. Let's go ahead and ask it to stop. We'll go ahead and go back to EC2, and we'll take a look at our instances. And we can see I already have a couple that are here, and so one of the things you can go ahead and do while that's stopping is you can see this create image EBS AMI. So you would go ahead and trigger this, and then your AMI will be will start creating in your AMI view. And you can see I already have a couple of these inside here. So I have one that I've used in the past for creating PHP layers. Let's go ahead and we'll go into OpsWorks, and I'll show you how you would use the AMI that you've created. So I'll go ahead and go into the instance view. I'll go ahead and create a new instance. And we can see that in my operating system, I can go ahead and pick Use Custom AMI. And I can select one of the AMIs. And so here I'll select the PHP AMI that I previously created. And I'll go ahead and start this up. And so inside that PHP AMI, I've already installed Apache and PHP. And so the benefit of using a custom AMI is, of course, that the boot times are faster because the software's already been installed. So basically, once that software comes on board, once the instance boots up, the software's already there. We can push updates, but those updates should be a lot less. Now, I mentioned that once we got the instances up and running, I'd show you the CloudWatch view. So let's go ahead and take a look at the data we're collecting from CloudWatch. So here we can see that I can get a view of all the metrics summarized by layer. So if I have multiple instances in, say, the PHP App Server view or the MySQL, this aggregates or averages those across all the instances, and so you can get a sense as to how your instances are doing. We can then, of course, drill down into any of these and see the actual instances that I have. So here I have 3 instances in my PHP layer. If I were to take a look at the MySQL, we'd see just 1. And I could drill down further and see all the metrics that we're collecting for you. So we have a number of metrics for CPU, memory, and load, and this gives you each of those metrics. So 4 metrics for CPU, 4 metrics for memory, and 3 for load. So you can get a sense as to specifically how your application's doing. Now you could also go to CloudWatch, and CloudWatch lets you create alarms for any of these metrics. So you could create alarms for any of your instances or for the average across all of the instances in a particular layer. And this lets you, of course, alarm on conditions you might be concerned about, like high CPU or high memory, and then you can take action on those. And so right now my instances are booting up, and once I have my instances booted, I'll go ahead and deploy my application to those. Now OpsWorks has a number of different layer types that we have built in. Let me just show you the ones that we have. We include a number of app server layers, but we also have something called a custom layer. And the custom layer lets you create, basically from a blank sheet, all the software that you want. So you might want to use a piece of software that we don't include, like maybe Solar. And what you would do in the Solar layer is you'd come in and edit this, and you'd put in all the custom chef recipes that either you've written or perhaps you've gotten from an open source repository, and add those for the appropriate lifecycle events. So to give you a little bit more background on the lifecycle events, the setup event is triggered when the instance first boots. A configure event is sent when the instance has come up to all the instances in your stack. And so this lets you, for example, trigger certain events to happen in your application that you might need to do when instances come on board. So I mentioned earlier the HA proxy example where you want your proxy server to know about new instances in your app server tier. So you could have a recipe in the configure event that has the HA proxy add that instance for routing. Deploy happens when you are deploying your application. Undeploy, of course, when you're undeploying, and then shutdown happens to perform cleanup on your instances, like shutting down processes or perhaps other sorts of cleanup tasks, pushing log files to a log file server and things like that. So the custom layer gives you a lot of flexibility on deploying really any software that is included with OpsWorks. And of course, you can use those same custom chef recipes to override and extend existing layers, and that's what I've done as part of this demonstration. So we have now our PHP app and our MySQL database online. So let's go ahead and we'll deploy our app. So I can click on Deploy an App. This is the app that I created earlier. And we'll open up these advanced boxes. You can see that I can push some custom attributes down. So perhaps I want to set a debug flag or something like that. I can send down attributes to my instances through this mechanism. I also can choose which instances get the deploy event. So the deploy event isn't actually itself pushing software. What it's doing is it's triggering recipes that are on your deploy lifecycle event, and those are what perform the actions that you want. So we're not actually pushing my PHP app to my MySQL database. We're instead running whatever the deploy recipes are on the MySQL database. And in my case, what I've done is on MySQL, I'm actually creating a table for my app on the deploy. I'm just kind of leveraging that. But there may be other things you want to do on the deploy event. So when I click deploy here, it's actually sending out that deploy event to each of the instances I've selected. And it's running those recipes on those instances. And then it's creating a log file for me. So if I were to select the instances that this has been deployed to, once the deployment is done, I'll be able to see logs. And I can see, of course, when I look at the history, the various deployments that have been performed, the user that's performed them, and other data about that deployment. So let's go ahead and we'll take a look at one of those instances and the log files that will be coming in here. So if I look at the instance, I can see, for example, this is running my custom AMI, a little bit of data about my instance itself. For example, things like public DNS name. I can see logs for the various deployments that happen. So let's just go ahead and we'll take a look at what these log files look like. So this kind of just lets you get some access to the logs without needing to SSH into the box. So you can see the result of your chef run. So this just if you're having if you want to take a look at this for diagnostic purposes or whatnot, it's just a little bit easier than having to log onto the box yourself. And these are generated for each of your chef runs. So we can kind of see that the status of our deployment is still ongoing. If we were to click into this, we could see the database deployment's finished because that was just very simple. It was creating a database table for us, and then the PHP app is getting deployed, and it's done. So we'll go ahead and now take a look at our click on our public IP. And of course, that's not the result we were hoping for, but that should have actually brought up the app main page. I won't try to spend time in this demonstration looking at what step that I must have missed. Apologies for that. Why don't we instead switch over into Q&A and get questions from you. You can use your Q&A panel to send me questions, and be happy to answer those for you. And so a question on should OpsWorks be used to scale Tomcat 7? So OpsWorks could definitely be used to scale applications like Tomcat that can be horizontally scaled. So basically the instances that you scale will come up with each one will have the same configuration as the last. So in my PHP example, for example, I could create multiple PHP instances, and as long as those could be horizontally scaled, then I can route traffic among them. A question on how does the initial authentication to the instance work if there's no SSH key. So basically, OpsWorks installs an agent that securely handshakes with the OpsWorks service, and that's what is used to communicate. So you actually don't need to have any SSH key on those instances. The OpsWorks agent is sent a key that allows it to securely handshake with the OpsWorks service, and then that's how we pass down the chef recipes that need to be run. Question on, is a stack roughly equivalent to an environment? I guess there's so much, so many different ways to define things like environments. I'm not sure. I guess it depends on how you define it. Stack certainly could be equivalent to how I think of an environment, which might be, your staging system for a certain application or your production system for certain applications. That's definitely a valid way of thinking about stacks. One thing I didn't mention in the demo is that you can clone stacks very easily. And so what that allows you to do is, if you are pushing new code to a staging environment, you can test it and confirm it works. Then you could clone it and have that be your new production environment that you, again, perform additional tests on, and before you end up starting to route traffic to it. So that's kind of a common pattern that we see is people creating new stacks for pushing new code so that they're not kind of pushing code to their existing production environment. Question on, is it possible to store the JSON metadata somewhere like S3 instead of inside the recipes themselves or inside the custom JSON? And the answer is yes. In fact, that's a great design pattern for sensitive data. What you could do is basically put your attributes into a file on S3, and then you would protect that object and use your role to get access to that object. So one thing that I didn't cover in the demonstration was that your EC2 instances are brought up with a default role that has no policy at all. So that means that the instances themselves aren't able to perform actions using the SDK or CLI until you grant them that permission. What you could do is add the S3 bucket as a allowed object for those instances to access, and then you could pull down your sensitive metadata while the instances are running and use that as part of your recipes. So that's definitely a valid pattern and one that we see people doing. Great question. Question on OpsWorks and RDS. So there's actually a section in our documentation on how to use OpsWorks with RDS. It's very straightforward. You can also use OpsWorks with MySQL running on EC2 instances. So either one, it kind of depends on if you want to use a managed service like RDS, which makes things a lot easier for you, or whether you need to run your own MySQL. Question on why install the CLI tools via SSH? Shouldn't use a custom chef recipe. Yes, that's definitely exactly the right thing to do. You shouldn't install the CLI tools via SSH. That was kind of more just as a demonstration type thing, but you're absolutely right. Question on OpsWorks and VPC. So today OpsWorks supports the default VPC, which and the default subnet, which gives you fairly minimal VPC support, and certainly understand that there's many folks out there that want to be able to use multiple subnets with a stack. So we're hearing that request a lot, and we certainly want to work on things that we're hearing a lot from our customers. So we appreciate the feedback that you need VPC support, and please stay tuned. Question on CloudWatch. Any recipes created by AWS that automatically set up per server CloudWatch alarms? We don't have any recipes that do that. The thing that I guess you could do is to set up per layer alarms, but that may not get you the sort of detail you want. It's a good thought on us providing some recipes that would let you do that more easily. But I guess certainly you could do that on the instance setup and using the CLI create those yourself. So a little bit of work there for you, but it's a good piece of feedback for us. Thank you. Question on, can you show how to manage the metadata? Let me go ahead and I'll see if I can bring up the screen share again so that you can take a look at that, since I didn't cover that very much. So on the stack, there's the ability to set a stack-wide custom JSON. And so I could go ahead and put inside here attributes. So there's a few different places you can put attributes. You can put them in an attributes file inside your cookbook. You can also put them here in your JSON. You also have the ability to set deployment JSON. And there's a section of the documentation that kind of walks you through all the ways you can set these attributes and the order in which the precedence level of each of them. But this is kind of the easiest way for you to basically push down a standard set of metadata to all the instances inside your stack. This is where you do it. Question on how would I set up a different stack like Python? So you would create a custom layer is what you do, and then you would put the Python recipes into your layer config. So there's a number of recipes in the open source, or you could create your own. Recipes could be as simple as just wget these packages and then install them. So you don't have to go too crazy on the chef configuration. It really depends on how much you need to do. And then of course another alternative is to use a custom AMI. So the custom AMI feature I just showed you, you could create an instance in EC2, install all the packages you need, then create that AMI, and then use that as the foundation for your instances. So those are kind of all the ways that you could customize OpsWorks. Question on OpsWorks and Windows. OpsWorks does not support Windows today, but we definitely appreciate your input. And There's a thread in the forums if you want to +1 there, but I'll certainly take your feedback and +1 it on my side. Really appreciate your feedback on what you guys need, because we set our roadmap based on the input we get from our customers. Question on using OpsWorks and CloudFormation. Is it one or the other, or both? We see that there's a good use case for using both, particularly if you want to provision aspects of your environment in a consistent way, things that might be used with OpsWorks but aren't necessarily part of your OpsWorks environment. So maybe you create an S3 bucket for logging, and you create different IAM roles and IAM users. That would be a good use case for CloudFormation, is to create those resources that you're then using with OpsWorks. Is there anything to distribute an app across multiple nodes in a smart fashion when trying to process lots of data? I'm not sure I quite understand that. I mean, so we provide you some scaling options that let you scale up by time or load, and then your app, using a load balancer, your app would have those requests distributed across that set of instances in whatever mechanism that the load balancers give you different options for how you would distribute that load. So I guess without having a lot more detail on your application, that's probably the best I can give you there. Question on, can individual EC2 instances belong to more than one layer? The answer is yes. Inside OpsWorks, when you add an instance, there's an option for whether you want it to be a new instance or an existing instance, and that's how you could add it to multiple layers. Question on full API support for everything I've shown. Yes, the SDK and CLI, basically the console is built on the SDK, so everything that you see in the console is available through the CLI and SDK. So a question on, when applying additional security group rules, OpsWorks ignores the rules that are closing port 80 and 443. Why is this? So this is actually how EC2 security groups work. It's not OpsWorks, and so this is actually probably pretty important. If you want to restrict, you can't apply multiple rules and create restrictions. You'd actually have to modify the existing OpsWorks security groups. And I know that right now it says do not modify. We need to modify that language, because you certainly can modify it. It's just we want people to be aware that when they modify it, that those changes do have implications. So there's some documentation on how EC2 security groups work together, and unfortunately one of the things that how EC2 security groups work is that basically it gives you the permissions of those. It doesn't restrict them if you have a second more restrictive security group. So a question on using EBS in a layer. So you can attach EBS volumes. When you put the definition in the layer, what you're actually doing is saying that any instance in that layer is going to get the volumes that you specified in the layer config. And then when the instance is booted, those volumes get attached. When you stop and start the instance, we maintain the association of the volumes with that instance. So when you start it the next time, then the same volumes and the same configuration are associated with the new instance that might get created. So that's really kind of how block storage works with your layers. Public IPs, why do they change when restarting an instance? And this is just a side effect of how EC2 works. So we're using EC2 under the covers, and when you stop and start instances, the IPs don't persist in EC2 unless you use an elastic IP. So you can specify in the layer to use an elastic IP, and then if you do that, then that elastic IP is bound to that instance until you delete the instance. So if you want the public IP to stay the same, then use elastic IPs. Otherwise, the public IPs do change between instance stops and starts. So using OpsWorks with DynamoDB, you could use it in a similar manner to RDS. We have the RDS example in the documentation, so you could just specify using that custom JSON for example, the name of your database and any sort of connection parameters you might need in order to get to it. Question on support for Chef server. So today, as I mentioned, we have Chef Solo on the nodes, but we provide a lot of the Chef server functionality. So you can perform searches of the attributes on your nodes in your recipes. You can iterate through the attribute file through the node attributes. You have support for push. You have support for events that go across all of your nodes. So there really is, I think, a strong similarity to the functionality of Chef Server, with the benefit, of course, that you're not having to host a Chef server. So the OpsWorks service gives you those eventing mechanisms and the management of your recipe of the recipes to those events and the attribute management. So I encourage you, as you look through it, if you see things that where you need additional functionality, we'd love to hear from you in the forums with the use cases that you're finding that aren't working as well, and we'd be happy to kind of respond with how we think you might be able to do that, or if there's needs, then we can look at how we prioritize those in the service. A question is there an OpsWorks tech blog? Unfortunately, not yet. That's definitely something that we're looking at doing, and so thank you for the request for that. Good to know that there's interest in the community for a tech blog. I've seen a couple more questions on Windows. So I just mentioned that no support for Windows today, but appreciate the input. We do prioritize our roadmap based on input from customers and prospective customers. So I really appreciate that. Question on how does the custom AMI know how to deploy your code? Yeah, so basically what happens so you create the custom AMI, and that has a set of software that you've installed on the instance, and then we install the Chef, the OpsWorks agent, and so the agent then, when you deploy code, it will trigger the deploy recipes that you've attached to the layer that custom AMI is running in. I hope that's not too many layers of indirection for you to understand there. But those Chef recipes on the deploy event are what actually know how to deploy your code. So if you look at the built-in recipes for each of the layers, like the PHP layer and the Ruby layer, you'll see that what the recipes do is they pull the assets from the repo you've set up for your app, and then they install them in the right place for the particular application that you're deploying. So if you have a new type of application type, then you would need to wget or whatever those assets and get them onto your custom layer, and so you need a custom deploy recipe to actually perform that deployment. But if you're using one of the built-in layer types, then we're just using those existing deploy recipes. So hopefully that gives you a good sense as to how deploy works. So I'm probably kind of running out of time for Q&A. This is awesome Q&A. I'll try to take as many more as I can the next couple minutes. A question on support for Puppet, CF Engine, SaltStack, things like that. Again, right now just support for Chef, but we're very open on taking the OpsWorks roadmap and frankly in many different ways. So we appreciate the input, and we do prioritize the roadmap based on that. Question on, do all lifecycle events run on custom AMIs? Yeah, so basically the lifecycle events are triggered to the Chef, the OpsWorks agent. And so that agent's installed even on custom AMIs in the same way as it would be installed on the base Amazon Linux or Ubuntu images. So those lifecycle events and all the recipes you would associate with them also get run on custom AMIs. So yeah, when the custom AMI boots, basically when any instance boots in OpsWorks, we install the OpsWorks agent, and then there's a secure connection between the agent and the service to get those lifecycle events. And so when you push any of those events to the instances, then those recipes will get run. So I think we're at the top of the hour. I sincerely appreciate the fantastic Q&A here, and appreciate all the input too on things that you're looking for with OpsWorks. I think as was mentioned at the beginning of the presentation, we'll have a recording of the presentation, and encourage you to submit additional questions you might have through the OpsWorks forums.
Great. I'd like to extend a special thank you to our presenter, Chris, today, and thank you everyone for joining. Have a great rest of your day.